Okay, so if you live in the United States and you're going into ninth grade next year, there's one equation that is going to come up a lot during next year, and it's this one. Y equals mx plus b. Now, I'm going to do a video on functions, and if you're watching this video and you need help on this, I'm assuming you know what a function is. If not, this video might be a little bit confusing, so watch another video on functions before you watch this one. So right here we have the famous equation itself, y equals mx plus b. But why does that work? What does that even mean? Okay, to see what this means, let's take the case of this line. It's y equals 2x plus 1. That is its equation. But what does that equation mean? How does this equation come out to this line, and only this line? Why not some other line? Why not a line like this? Why not one like that? There are plenty of reasons. But let's look at what this equation means first. First of all, what does y even mean? In this case, y, which I'll denote in red, is the value of y at a given point. As you know, the purpose of a function is to relate two values together. Normally, the input function is x, and the output for the function is y. But let's strip that aside for a second, and we'll see that y, in this case, means the value of y at a given point. So here, you might say, what's the value of y? The value of y is 3. 1, 2, 3. What's the value of y at x equals 4? Would you look at that? 1, 2, 3, 4, 5, 6, 7, 8. At x equals 4, the value of y equals 9. So that just gives what the value of y is. And we have an equal sign to show that the left side and the right side will always be the same. Now, we're going to skip m for now and focus on x. So x is just value of x at a given point. Nothing special about that. It's similar to y. What is y? What is x at y equals 9? Well, look, it's 4. Now let's get to m. M is a little bit trickier because m will denote the slope of the line. Now, obviously, the slope usually means the steepness of things, and in this case, it's no different. So how does it apply here? Let's take a look at this line. Again, we have these 2 points right here, where x equals 1 and y equals 2, and x equals 4 and y equals 9. So if we want to find the slope, what we want to do is find how steep the line is. But what does that even mean? Well, let's say you have these 2 points right here, as we've demonstrated. Now, as you know, the more something rises over a lesser length, then the steeper that thing is. For example, Mount Thor, which is in Canada, is steep because it rises a lot, but over a very short length. Meanwhile, a random hill would have a lesser slope because even if it goes as high, it will, which it probably won't, it will be over a longer area, longer length, sorry. And it's no different here. As we can see, the amount that this goes over is 4 minus 1, or 3. Now, we can't just write 3. We have to know what we mean when we say 3. So when we're looking at what the length is right here, we call it delta x. As you can see, delta is the little triangle thing right there, and that means change. And this is the change in x. Same thing goes for the y. This is the change in y. And what is it in this case? It's 8. So the way we calculate slope is the change in the y value divided by the change in the x value, delta y over delta x. Now the last part we need to talk about right now is the y-intercept. Now the y-intercept is denoted by B if you live in the United States or Canada or Australia, and C if you live in Europe. And what does the y-intercept even mean? Well, simply put, remember the value of y and x from earlier? Right here and right here. As we can see, what we're looking for the y-intercept is the point where the line crosses the y-axis. However, we need to be precise with this. So what we want to do is say, well, on the y-axis, what does that even mean? Y-axis is where the value of x is always 0. So, and if where the y-intercept, therefore, is the value of a y when x equals 0. And there you have it. That is a quick and simple explanation to the hardest, but not hardest, but most common equation of the GL year.